All right, so hopefully you gave this a try. And the first thing we need to do is set up the system of equations. So we need to sort through all these words and figure out what they all mean. So for the opening night of My Fair Lady at the Pantages Theater in Minneapolis, a total of 1,000 tickets were sold. So let's underline that. That's good information we're probably going to need to use. Orchestra seats cost $80 each. Okay, so we got some different types of seats. Orchestra seats are $80. Rear orchestra seats are, I guess those are front orchestra seats, and then we have rear orchestra seats, which are $60 each, and then we have front balcony seats for $50 each. All right, the combined number of tickets sold for front orchestra, rear orchestra, and rear orchestra exceeded twice the number of front orchestra seats by 400. Okay, that's that's a little more complicated. And then we also know that the total number of receipts for the performance were $62,800. And we want to determine how many tickets of each type were sold. All right. Now, oftentimes the thing we're trying to determine is a good clue as far as how we need to define our variables. So the first thing we need to do is define some variables. And we're trying to determine how many tickets of each type are sold. So I'm going to just say that we're just going to make the variables equal to the different types of seats. And so X will be the number of front orchestra seats. Front orchestra seats. Okay. And we'll make Y be the number of rear orchestra seats. Whoops. Number of rear orchestra seats. And Z then will be the number of front balcony seats. Number of front balcony seats. Okay, so once we've got our variables defined, then we can go back to the words and try to figure out, turn those words into equations. All right. So the first thing we were told is that the total number of tickets sold were 1,000. And we're going to assume that there's just these three types of seats. All right. So X plus Y plus Z will give us the total number of tickets that were sold. Right. So that's 1,000. That's my first equation. Now, the other one that's probably easier to figure out is the total receipts. All right. And I know how much each type of seat costs, so I can just take the cost of the seat times how much, take the cost of the seat times the number of seats, and I'll get the total revenue from that type of seat. So if I take 80 times X, right, 80 times the number of front orchestra seats that were sold, I'll get the revenue coming from the front orchestra seats. And then the rear orchestra seats cost $60 each. So if I take 60 times Y, that'll tell me how much money is going to come in from the rear orchestra seats. And then the front balcony seats are $50 each. So 50 times the number of the front balcony seats will tell me how much total revenue I got from those front balcony seats. And I know the total revenue, the total receipts was $62,800. Oops, $800. All right, so there's two equations. Now there's this middle sentence here that says, let me highlight it. It's the combined number. Whoops, I wanted to grab a highlighter. I guess it's not going to let me change my. All right, so let's see the combined number of tickets sold for the front and rear orchestra. Okay, so let's write that down. Front plus rear orchestra. All right, so that's X plus Y. Okay, so the combined number of tickets sold for the front orchestra and the rear orchestra exceeded twice. Okay, so it's exceeded twice the number of front balconies, so 2z, by 400. Okay, so if we take twice the number of balcony seats and add 400 to it, we'll get the combined number of front and rear orchestra seats. Okay, that's kind of a trick to decipher those words and turn them into equations. But the combined number of front orchestra and rear orchestra exceeded twice the front balcony by 400. So that's just meaning we add it. If we add 400 to twice the balcony seats, we get the combined number of front and rear orchestra seats. All right, that's the tough part. That's the tough part. Now it's just a matter of setting up the Gauss-Jordan, setting up the augmented matrices. All right, we need to take these equations and set up the the augmented matrices. So these first two look okay because I have all my variables on the left side and a constant on the right side, but I have to rearrange this one. So what I'm going to do is I'm going to subtract 2z from both sides. So I get x plus y minus 2z is equal to 400. Now I have the equation in the form that I'd like it in order to write the augmented matrix. All right, so let's do that. Let's write the augmented matrix for the system of equations. All right, so this is just 1x plus 1y plus 1z equals 1000. Okay. The next one is just saying 80x plus 60y plus 50z is equal to 62,800. And the last one, we've got 1x plus 1y minus 2z is equal to 400. And that's my augmented matrix for this system of equations. Now we're just going to do row operations. All right, where do we start with this? All right, now I'm going to start with the first column. That's probably a logical place to start. And I already have a 1 in the upper left-hand corner, so that's a good thing. I'm just going to leave the first row as it is. 1, 1, 1, and 1000. Okay. Now the second row, I think I can just divide everything by 10. Maybe I'll just do that. I'm gonna start with that. Just to kind of simplify it a little bit. So this is kind of a baby step, but then I get 8, 6, 5, and I still get 6,280 if I divide, and just dividing that by 10. And I'm just gonna leave this alone. So I'm just taking a little baby step here. Sometimes baby steps are the best because it's you just have to kind of work very carefully and systematically on these. All right, now I want the first column to have 1, 0, 0, and I can use the first row to zero out the rows below it in the first column. So what I'm going to do is I'm going to take row 2 and I'm going to subtract 8 times row 1. I'm also going to take row 3 and I'm just going to subtract row 1. That's easy. All right. So let's do that. I'm going to make a little note to myself so I remember what is -8 times row 1, right? Because I'm basically adding -8 times row 1. So this becomes -8. This becomes -8. This becomes -8. This becomes -8,000 if I make my little notes to myself. All right, so but I'm not actually going to change row 1. I'm just going to leave it as this because I like having that 1 in the upper left. All right, so I'm adding -8 times row 1 to row 2. So 8 plus a -8 gives me 0. 6 plus a -8 gives me -2. 5 plus a -8 gives me -3. And then 6,280 plus a -8,000 gives me, let's see, what did I get? I got -1720. And now I'm just going to subtract row 1 from row 3. So 1 minus 1 is 0. 1 minus 1 is 0. Negative 2 minus 1 is a negative 3. And then I have 400 minus 1,000. So that gives me negative 600. All right. So it's getting there. I have zeros where I want them. That's a good thing. All right. So what can I do next? Let's see. I think I might do a couple of things. It might be good to I'm going to take the negative of row 2 just because I want that to be a positive one. I might as well it's negatives all the way across. If I just multiply that by a -1, that'll get rid of the negatives. I also see that I can take a -1/3 of row 3, right? And that actually gets a 1 where I want it down here in the lower right-hand corner. All right, so let's just do those 2 steps. I'm not touching row 1 at all, so I'm just going to copy it as is. All right, and then I'm just changing the sign of everything in row 2. This becomes 2, 3, and 17, 20. And then I'm going to divide, or basically multiply by -1/3. That gives me 0, 0, 1, and -1/3 of -600 gives me 200. All right. So now what should I do? I think I'm going to, well, I can see that I kind of want a 1 where I have this 2 right now. I have a 1 there. But if I divide everything by 2, then I'm going to be working with fractions. I mean, 1720 is even, but then I'd have to work with the 3/2 here. So I might just leave that for now because now I have this last row looks good. I like the last row. In fact, I can tell right now that Z is equal to 200, right? So the number of front balcony seats has got to be 200. I'm going to use that to, before I finish up row 2, again, this is just to avoid fractions. I'm going to use row 3 to zero out the columns above it. I think that's probably the best approach to take on this one. So what I'm going to do, I think what I'll do is take, I can take row 1 and subtract row 3. Okay. I can also take row 2 and subtract 3 times row 3. All right. That'll get some zeros where I want them. And it might help because then it gets rid of that 3, which is the thing that's kind of muddying up my my efforts to get that 1 in the center. I want to turn this 2 into a 1. All right, so that might help. Let's see what happens when I do that. All right, so this is all strategy. You know, there's not just one way to do these problems. It's a game of strategy. So, all right, so I'm going to subtract, take row 1 and I'm going to subtract row 3. All right, so 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. And 1,000 minus 200 is 800. Okay. And then I'm going to let me make little notes to myself. So this becomes a -3 when I multiply times -3, and this becomes a -600 when I multiply times -3. So I'm just making little notes to myself so that I don't get confused. So this becomes 0 plus 0 is 0. 2 plus 0 is just 2. And then when I take 3 plus -3, I get 0. And then 1720 plus a -600 gives me 1120. And I'm not doing anything to the last row. I'm just going to copy it down as is. Okay, so I'm almost there. I'm so close. I'm so close. Next thing I want to do, now you can see, now I can divide that second row by 2 and not get any fractions. So I'm just going to take a little baby step here and take 1/2 of row 2. All right, not going to touch row 1. I'm going to take half of row 2. So half of 1120, that'd be 560, 560, right? And then 0, 0, 1, 200, leaving that row alone. The only thing I have left to do is to get this 0 in the first row, second column. And I can use the second row to do that. I'm just going to take row 1 and subtract row 2. Okay, and then I'll get a 1 where I want it. All right, so when I do that, what I'm going to have is 1, 0, 0, right? I'm just adding or subtracting row 2 from row 1. So I get the 1 minus 1 here. Everything else just stays the same. And then I have 800 minus 560, which I got was 240. Okay, and then everything is the way I want it now, right? I can just copy the second and the third rows down as is. And you can see I won. I win. I've solved the puzzle. All right, I've solved the puzzle. I have my the matrix in the form that I want it, and I can just by turning this augmented matrix back into a system of equations, this tells me that x is equal to 240 and y is equal to 560 and z is equal to 200. Okay, that's the solution I got. Now, it never hurts to check. It never hurts to check. So if I remember right, I had a total of 1,000 tickets sold. So if I add up 240, so this is my check, 240 plus 560 plus 200. Does that equal 1,000? I add those up and I can see, yes, that works. All right, now I wanted my total revenue to be a certain amount. So 80 times 240 plus, let's see, these tickets cost 60, so 60 times 560, and then plus $50, $50 times 200. I need to get out my calculator for that, but when I do, I can see that that does indeed add up to $62,800. And then the last piece of information was the fact that the sum of the front orchestra and rear orchestra seats, so that's X and Y, 240 plus 560 should be equal to 2 times the front balcony seats, right? So 200, 2 times, hang on a minute, 2 times 200 plus 400, okay? And we can check to see if that works out. So we have, 800 over here and 800 over here, so boom, that works. All right, so we found the solution. And we verified that that is indeed the solution to the equations we set up. All right, these problems can be a lot of work. So we got a couple of discussion questions, basically one of each type. So hopefully this will get you started on that. And it really just takes practice. That's all I can really say about this. You just have to practice this Gauss-Jordan elimination. Okay, so that's all I have for this lecture, and I'll see you in class.